but real value or repeatable value, it's more important.
I think you have to really know well what you are doing in order for you to make the part okay or not okay.
No, come on, everybody can do it. It's very easy.
Hello everyone and welcome back to XYZ Architect, this time in a brand new format. Before we begin, I would like to thank each and every one of you for your support. To my YouTube members and my Patreon community, this episode exists because of you. Your support helps me bring valuable conversations like this one to the entire metrology community. Today we have a very special guest. I'm joined by someone who has shaped the knowledge of technicians and engineers throughout his career. With me is Paul Ionescu, a former AUKOM trainer and an expert in coordinate measuring education, and someone from whom I personally learned a lot. Thank you so much for being here, Paul.
Yeah, thanks for having me here. I'm so glad to do it. Nice setup.
Yeah, thank you. Okay, so first of all, Paul, please tell us a bit about yourself. Tell us who you are. How did you start working in coordinate measurements, and how did you become an AUKOM teacher?
Yeah, getting into the measurement world was by chance. My friend Vali had an opportunity, and he said, "Okay, look, you have 2 days to learn this stuff. It will be an interview with a test, so just do it." And I was glad to do it because it was a brand new world.
Mm-hmm.
So to have a CMM, nobody knew at that time what it was.
Mm-hmm.
It was a nice machine, very clean, in a room.
A cold room.
A cold
right.
room.
Okay.
It was 2003.
Mm-hmm. Okay.
And I started in Drexelmeier company.
Mm-hmm.
They were making wooden parts for car interiors. Very simple measurements, just space points. But then we evolved to measuring jigs and verifying fixtures,
Mm-hmm.
and also molds for shaping the parts.
Nice.
Yeah.
Good.
Yeah.
And what roles did you hold over the years in this field, in the field of metrology and in the field of trainings?
I was a CMM programmer.
Okay.
And then because I was kind of alone,
Mm-hmm.
I had to train people because after this I was working at a partner of Zeiss.
Mm-hmm. Mm-hmm.
And they had to fulfill also the trainings, not just installing the machines.
Mm-hmm. Mm-hmm.
So I said, yes, let's go. Made the trainings of Calypso. And after some time, the customers requested more.
Mm-hmm.
Not just technical knowledge of how to use the machine or the software, but also how to figure out what the drawing means and what was the specification.
Correct.
And this was the time that we found about AUKOM.
Mm-hmm.
And I attended the training. It was very nice material, and I asked, may I be a trainer of AUKOM too?
Okay. So it was kind of like a passion for you.
Yeah.
And it still
It
is.
still is.
Okay. Yeah, I can confirm that. Each time I call you to ask about something, you always give great answers, and I thank you for that. Okay. For those who might not be familiar with what AUKOM means, what does it mean, and what problem is it trying to solve in the metrology world?
AUKOM, it's Ausbildung Koordinaten Messtechnik for your German friends.
Okay.
It came from an university background with the help of the German government. They tried to standardize the way of thinking and the way of communication, how the communication is done in the metrology world. They are backed up by the German car manufacturer group.
Okay.
And they have a lot of partners. Now, I think all the OEMs like CMM manufacturers are involved in AUKOM in some way. Also the software producers for measurement. And they have a nice way to explain what is what and not really how to do it, like in Calypso trainings, but a way of thinking.
Yeah, that's great. I also saw on AUKOM site that they have a lot of support from, as you said, from manufacturers. I saw their Volkswagen, I saw Zeiss, I saw Hexagon, I saw a lot of them, Kayens and so on. I also saw that they started, as you said, in 1998 or something like that, and all the procedure for making AUKOM has lasted like 3 years or something like that.
Yeah, it was a program, it was a trial, and then it became a reality. It was focused on German world, manufacturers, and after some years, because everybody wanted to join, they expanded, and now they have a program which is worldwide.
Yeah, 12 countries and still counting.
Yes,
I think so.
Yeah.
That's good. That's good. Okay, let's go back in time a little. Why was AUKOM created, and what problem in the industry was it trying to solve?
The measurement industry, it was not at the beginning, but still an infant, and everybody was talking in his own language. So very hard to understand what another guy from another laboratory did, or what the report has in it. So they tried to make sure that everybody understands what ISO means. Nowadays also ASME, because the world got bigger, and they are also trying to emphasize the fact that communication is the key. So between common language and communication, and also the knowledge of the CMM programmers, technicians, quality management, everyone, that the measurements are not exactly those values. There is always an uncertainty that is coming with the value.
Correct. And that uncertainty,
it's unknown until it's measured.
And can be produced by something like
everything
from the room temperature to
To
the way we
speaking
position.
too loud
Yeah,
or
yeah.
having too many people around the machine.
Mhm.
Everything can have an influence on the values.
But people think this is something exaggerated, you know.
Yeah,
But
it depends on which field you are working. If you
Mhm.
are working on a field of 1 millimeter, then it's no problem.
Mhm.
If you are working in a field of some microns, then you have to take care of everything.
Okay, and Paul, how did AUKOM evolve from the early days to the structure that we have today? Today we have AUKOM level 1, level 2, level 3, GD&T, expert, and so on. So was it like this in the past also, or how was it?
Yeah, it was always structured as 3 levels because they are coming from academy background. So it was structured like a stair. Even on the picture on the site, it's a stair. So you have level 1, which is the basic. Then you have level 2, and level 3, which is for experts on top. The GD&T was added because it was a separate course, and also they included they made another course for surface profile measurements. It's another world from the coordinate measuring machines, so they made it separately.
Surface profile, you mean when measuring with optical scanners, or it doesn't matter?
No, with contour measuring machines or roundness machines.
Okay.
Because if you have a CMM, you're talking about inaccuracy of some microns, 2-3 microns plus something. If you're talking about roundness machine, you are talking about 0.5 microns plus something.
So more precise.
More precise, more fiddly. It's not like CMM you just take apart and put it somewhere on the table, glue it with the plasticine, and it's gone.
And who contributes to building and updating the curriculum for AUKOM? Is it industry experts, OEMs, universities, or is it a mix between those?
It's a mix. It's a mix. For the 3 main chapters, it's OEMs mainly, and for special chapters in the expert level, it's experts. They have an expert on
GD&T?
uncertainty measurement, because you can measure the uncertainty, and that uncertainty has an uncertainty. I was at a fair, and this nice person was talking, and the other guy, because the time was limited, said, "Oh, please, don't talk about measuring the uncertainty of the uncertainty."
Yeah, we don't want to go there also, because we would stretch
too far.
Yeah, too far, and it will take a long time. How do you see AUKOM role compared to OEM specific trainings like Zeiss Academy or Hexagon, or international trainings from OEMs in automotive or in aerospace?
AUKOM, it's better structured, and the knowledge, it's going on to a curve that is nice. How to say it? It's shaped nicely. So they have a lot of experience.
Structured.
During the years, they change the structure a little bit. They fine tune it.
Okay.
And as I said, they are beginning with beginning, so very easy, not very tough subjects, and they are going up, and depending on the level of training, you are going to get more knowledge and more knowledge.
That's good to know.
Yeah,
it's good to know for everyone who's looking at us.
Yes. And it's not specific to a software or a machine. They even took out the pictures of the OEMs. So it's not, you will not find a Zeiss machine. You'll find the machine.
Yeah, correct.
Yeah.
Correct. That's good.
Yeah. And this way of thinking, it's like a golden path, like Calypso cookbook. The cookbook, it's for Calypso.
Correct.
But AUKOM trainings are for anything.
For everyone.
Yeah.
That's very good. It's good to know this because maybe there are people who are looking at us right now and they don't know where to go to learn everything they want to learn, and maybe they are scared that the information is too big and so on. So they now know that level 1 is not that scary. They can go and
they can surely go there. They can go to the local partner and find out about the trainings.
We recommend this. Let me see what other questions we have here. Okay. Why is standardized terminology so important in our field?
Because if not, everybody will talk their own language. Not even if you speak English, you are thinking about a circle and the other guy thinks it's a square. It will not work. So having a standardized way of talking, everybody understands easier what you are trying to say.
Okay. So
because not always you can show pictures.
Correct. So we have a universal language, that's the technical drawing. And AUKOM is trying to make a universal language of how to interpret that technical drawing, each side the same way, right?
Yes. By each side, you can say different laboratories.
Yeah, correct.
Or design and measurement.
And production.
Or production.
Yeah, because
everybody is reading the same thing, and the understanding of what's inside the specification should be the same. So for now, the AUKOM trainings were mainly for measurement technicians or programmers, but also for quality department, also for design department.
So it has evolved.
It was pushed to those because the financial department says, if you are working in production, you don't need to know about measurement. If you are working in design, you have already the knowledge of measurement, which is not true.
Correct. That's right. When training new technicians, Paul, or engineers, what knowledge gaps do you see most often? And what is usually the biggest aha moment for the trainees?
It's not always the same. It depends on the background knowledge of everyone. In Romania, the trainings are costly. So I had more skilled people, let's say. I didn't had very basic people on the first day of work.
Okay.
It depends on everybody, but everybody had something new found in the training, even if it's basic training. Coming from an alignment or something about the machine or the internals of the machine. Somebody was amazed of how many types of machine there were.
Yeah.
Because you can have machines very small or very big, and seeing them all on a page, you realize that the metrology world is not limited to your 4 walls and 1 machine.
Correct. I liked when you said that there's a small CMM inside the head, the measuring head.
Yeah,
of
my
the
joke.
CMM.
Yes. Yeah, because you have a small measuring device. It's 3 axes, and it's measuring all the time, like the linear axis of the machine. And yeah, you have better results by having this kind of equipment.
And for level 2, and I'm more curious about GD&T. What's the aha moment? Level 2, okay, but I understand that probably, I don't know if there is some aha moment, but
yeah,
clearly
for sure. Even for me, it was something new and extraordinary, like a light bulb.
Okay.
Oh, that's it. Very nice. And in the GD&T, it's mostly everything.
Mostly everything.
Yeah, because we don't have a very good knowledge about this. Coming from the university, you know how to make a drawing, but you don't understand what to put inside. The university courses are mainly based on fits. You know how to dimension a hole and a pin very good, and mainly that's it. At least at the time I was in university. Hopefully they are doing a better job these days.
I think they have evolved, but we do need more and more information as we progress in our career. Of course, this is important. Okay. What's the hardest concept to teach in dimensional metrology?
The hardest concept, it can be alignments.
Okay.
Because there are some people that don't understand how could you fix something without fixing it. I'm taking a part like this and say, okay, this part can float in space, and you have to fix it somehow. And you have 3 degrees of rotational freedom and 3 degrees of transition. And this should be fixed. Sometimes it's easy, sometimes it's hard. If you go from the simple part like this to a part like this, it becomes a little bit trickier.
Complicated. How do you approach trainings GD&T GPS to someone that has never seen a technical drawing?
I've made for the trainings a cube, which I split it in 4 quarters.
Okay.
And I'm using it to explain the views and the section of the drawing.
Okay.
Because if you understand how the views are made and also how the sections are to be understand, then what is a hole, what is a distance between 2 points, what is an axis, can be more easily explained. After that, explaining datums, and after that, all the features that can be in the drawing. Sometimes it's easy, sometimes it's hard. It depends on everyone.
Who you are
Who you are
teaching.
talking
Yeah.
with.
Okay. From your experience as a trainer, what makes someone a good measurement engineer and not just a button pusher? Because you know that these days everyone wants to know where to click and where to push a button,
Yeah.
not exactly where why you have to push that button.
Yeah, I heard a funny thing at an induction for production on a machine. I don't know which machine, but it was very nice put it. You have the raw part, you put it there, you clamp it, and then just press play, and the machine will do everything. Coming back to your question, good engineer should be curious. Curious about how to measure, how to explain the values, how to see the weak points of the part. But that needs to know the production processes, the materials, and also the function of the part. Because you can have any answer from the machine. As a colleague said one time, the CMM can give whatever value the programmer wants.
Correct.
So you want the part to be in tolerance, I can give you that value. You want it outside tolerance, I can give you that value. But real value or repeatable value, it's more important.
Yeah, correct. But even like this, I think you have to really know well what you are doing in order for you to make the part okay or not okay.
No, come on, everybody can do it. It's very easy.
Okay, if you say so. Okay, yeah, I like that you said that you have to be curious, and I also agree with this. You have to go in production. You have to see the part being made, and you have to feel what's going on there. And to managers, please let the CMM guys or the measuring engineers go inside the production and see the parts, because it's very important. That's the way that they make sure that understand how the part function. Okay, when planning a measurement strategy, what are the first questions we should ask? I think this is an important question.
Yeah, a couple of questions, not just one. You need to know the function,
Okay.
how the part is assembled, how it will look when it's doing its job, how it was made, the specifications from the drawing, and then the equipment you are using, because you are choosing the equipment based on the specification. This is the theory.
Okay.
Then you find out in the real world that you have only one machine, and you have to do it. You have to adapt your strategy. You have to adapt your evaluation to fit the specification with what you have. Because not always you have the best equipment to do the job.
Correct. And you have to adapt each time. Yeah, we have to be something like detectives and search for the best way to find what's the problem on the part and so on.
Yeah. If you have the part, it's easier because you can see it, you can make an evaluation, some program just to find out how it's working, if it's working. If you don't have the part, then it's a little bit tough because you have to imagine how the part will look like and just make some changes based on that.
And what's the approach here?
Yeah, the approach is do your best, and then when the part arrive, also the fixture adapt. Because you can make a program,
offline program.
I've done this. I talked with the guy from the quality, I think quality department or purchasing department, and I asked, what machine are you using? This machine, big machine.
Okay.
Made the program, and then the customer received the program, the fixtures, the probes, put on the machine, another machine, a smaller machine, and the program didn't work.
So it's important when you do something like this to have a conversation with someone in charge of measuring, not someone from purchasing, because they usually don't know the equipment and so on. Yeah. Okay. How do we choose what to measure and what to ignore?
If the measurement request is everything, then most of it.
Yeah, so we don't ignore anything.
Yes. Yeah. If you have small features that are smaller than your smallest probe, then you don't go there. Maybe they understand and say, okay, maybe
skip those.
If you have specifications with a small tolerance which cannot be fulfilled by your uncertainty of the machine, then you try to skip it. If it's really necessary, then you make do. Because you have to do it.
Correct.
But always you have to try to make a program that gives real results. Even if your uncertainty is a little bit bigger, then you have to explain to the customer or whoever needs the values that this is the extent that you can do it.
The best
you can do. Yeah, maybe they understand, and maybe if they don't understand, you have to go outside your laboratory and measure it somewhere else.
Correct. So yeah, we have to search for better instruments each time if it's possible.
Yeah.
Okay. Could you share an example where changing the measurement strategy solved a major measurement problem?
Yeah, it was a nice story about this. It was kind of late during the day, close to the end of the program. My colleague from production came, said, Paul, please help us because today we milled a lot of parts and the laboratory is giving us confusing results and feedback. You have to go right, you have to go low, you have to go up, you have to go left, but we are never in tolerance.
Okay,
and the funny thing is, it was that the part was a U-shape part,
okay.
long, with 2 holes, 3mm holes on each of the U side.
Mm-hmm.
He had the part on a carbide rod, and he was spinning it. He said this part has 0.3 millimeters deviation. So how is possible?
What was the specification?
The specification was on the one side of the part, one hole was the reference, and on the other side, the other hole was the element to be evaluated
as a position.
as a position tolerance to that reference.
And they try to match.
Yeah, they
the
tried to
holes?
match it because they didn't have a drill long enough, and they were thinking that the drill might drift, not to have problems. Drill on one side, switch the sides, drill
On
the other side. And because of this, they were thinking the machine was shifting somehow, not indexing correctly or going up or down or whatever. Because, the measurement laboratory is always right. So the problem was the specification, because there was a hole with a small length. So the ratio between the length and the diameter was less than 1. And having this ratio, it's always tricky, because the software can calculate an axis which is not the real axis. And having a distance between those 2 holes, the error it's amplified by a few times.
Correct. Yeah.
So I changed a little bit the program, took 1 circle on the outside of the part from each cylinder, made an axis, changed the position to each of the small axes to the long reference. The results were extraordinary on all the parts.
Which is why the guy could do
could spin the part.
The spin, yeah.
And when they asked the customer, please let us do it like this, because we have good results. And the other way of doing it was giving us bad numbers. And the customer said, yeah, we do it like that.
Okay, so they already
they already knew about this, but the specification, it's the specification.
Yeah, okay.
You get it, you think it's okay.
Yeah.
Usually
what we do.
It should be okay. Because one of the things you can find in all of the trainings, it's if you are having a reference system, please get the biggest and the element that has the least amount of form deviation to be the first reference. Then the others, whatever, but try at least the first reference to be big and stable. Everyone says this.
Yeah, exactly. I also teach this in my channel as well. All the time I try to say to everyone, pick the biggest and the stable reference that you can from the part. It's very, very important. Although I had someone that told me that I'm working with casting parts. So
even the casting parts, you can measure them. Usually the tolerances are big.
Just keep off the scanning. No scanning on casting parts. If you don't want to break your stylus, if it's small.
Depending on the casting, because usually the injection molding, it's nice. You can have nice parts.
Yeah, yeah. But why do you think measuring engineers focus too much on the software and not enough on geometry, function, and the principles? Why do you think they have this approach?
Because they are taught like that.
They are taught like that.
Yeah. The first thing they encounter, it's basic training for using the machine and software.
Mm-hmm.
And in the basic training, there is little to nothing about the drawing specification
Mm-hmm.
and how to approach your strategy, measurement, evaluation.
Mm-hmm. Mm-hmm.
It's just an overview. This is how you do it. And most of the times
They think this is enough.
This is enough.
And they just want to learn more and more about where to click and where to find how to do things.
How to do things,
not
yes.
not to better understand why they should do things like this. I saw this misconceptions on my channel as well. I have some videos where I talk about how to interpret flatness, how to interpret parallelism, and they are the most underrated videos that I have there. Nobody is watching them, or at least not that much as I set out a video, for example, on how do you get to do flatness in Calypso, or how to do parallelism in Calypso.
Okay.
You know, it's a very big difference between the viewers. They want to know how to do the flatness, how to do the position, how to do everything inside the software, but when it comes to understanding what they should understand from the results, that's not that interesting.
Yeah, because you're going to interpretation.
Yeah,
which is another thing that they should know. Flatness is a flatness. Come on, it's a flat thing.
Okay,
yeah,
okay.
It's flat. So what do you need this?
I saw flatness with the into sometime on a drawing. I think they meant for it to be a profile, not a flatness, but
it's a drop down list, and you have to choose flatness is the first.
Okay.
Yes. Everybody's focused on the technical side of how to do it because they don't have knowledge of how to check it with simple gauges.
Mm-hmm, mm-hmm.
If you start from or not start, just
are curious
know
mm-hmm.
about how to do it with simple gauges,
mm-hmm.
Then you will know something more,
mm-hmm.
and also focus more on the how to explain what the result is. Mm-hmm. Because in the measurement software, you have a flatness, as you say. Mm-hmm. You have also report with a nice picture. That's it.
Yeah,
you have this picture. What do you mean? So this is the flatness. I didn't measure all the surfaces, just here measured, but this is representative of your part. Also, on the other side, the guys from manufacturing, which are using the simple gauges,
mm-hmm.
Have a big confusion between form tolerances, implied form tolerances, and position tolerances. because many times they are measuring parallelism, and they think they are measuring flatness.
Because they set on something like a table,
and they're measuring with a dial gauge. They are measuring the parallelism, and they said this is the flatness. Or they are measuring the distance, the height of the part, and they say they are measuring parallelism. In a factory, they were grinding flat parts, and it was an old guy. He knew how grinding works. He knew how to do a very parallel part, but he was still measuring with the micrometer.
Okay, Paul. In your view, what's the most misunderstood symbol or concept in GD&T?
All of them. From position tolerance to surface profile, even linearity. Because it was a moment I was explaining linearity.
Okay.
And in the example, it was surface like this, rectangle. And depending on the view, you have linearity on the long side and linearity on the short side.
Yeah.
And somebody said, but linearity is linearity. Yeah, but you can have a tolerance on the long side and another one on the short side. It depends on how the part
is
oriented and it's working. Because you can have something that slides over it, or this part enters in a slot. It depends on the function.
And they got confused.
Yeah.
That's a very nice example. Thank you for this. How do you explain the concept of datum system in a simple and intuitive way?
Datum systems and alignments go hand in hand. And I'm still using this part. And I'm going to make a fixture. Like you have this part and you imagine a fixture for it. So this backside, it's datum A.
Yeah.
Hopefully. The first reference, you have to put it on a fixture plate. And it will stay on the highest points. Then you need another side, like datum B. And this you touch on a very straight line made by the fixture. And then you have another point that is datum C, and you push it on the point. The datum system, it's coming here in this point. I'm showing this to your viewers. It's going to be to have the 0 in the corner.
Okay.
And it's floating until you do this alignment. So a datum system, it's in the specification. You will find it in different ways. Just a point on a surface, or some small points that are making this datum. And your reference system, which is 3 axes, with a 0 point. Usually I have a small 3-axis system, which I use it to explain it. And these 3 axes should be linked to your part. This kind of jig that I made, it's linking this axis to your part. Sometimes it's easier because I get something like this. Sometimes it's harder because
you get freeform.
You get
parts,
freeform parts, so you have to change from the 3-to-1 method to an RPS method. And then you start to explain RPS. What is it? It has 6 points as the other one.
Yeah.
Why do we need it?
Exactly.
We need it because you have freeform surfaces and your part has no simple features. You don't have planes, you don't have holes, you have just some shape. And this kind of method is used in body panels in automotive industries. You have just one panel that is there. You have to somehow fixture it and align it. So you're using 3 points for
imaginary
something
plane,
like
right?
a plane.
Yeah.
But they are on the surface. You're using another 2 points for something like a line. And another point as a point.
Yeah. And
we should go to Best Fit. We stir up the spirits or not?
I don't know. What do you want to talk about Best Fit?
Best Fit. It's the best way to figure out problems on the part. Nobody likes it because it's not precise. It's not repeatable. Why should we use it? But when you have a part with unknown problems, Best Fit is your only way out of it. Yeah,
that's right.
And you can do reverse measurements. You take your specification, use the elements that are
inside
are
the alignment
to be evaluated.
Okay.
And you're using those elements as references, and you measure the reference datums. Because maybe one of the pins on your part is bent, and that pin is the 0 pin.
In relation to the Best Fit alignment, right?
Yeah.
Listen what Paul has to say. He always teaches me things like this. Okay. Paul, how do you handle a situation where production claims that measurement are measuring wrong, and metrology claims that parts are being made wrong? And how should metrology support production, and how production should support metrology? It's a very long question.
Yes,
Sorry.
yes. But a very nice one.
Yeah.
And if you have the possibility to mediate, then you just have to construct a ring, put some guys in, and fight. Yeah. Because it's a well-established thing that the production is making bad parts, and metrology it's measuring wrong. Yeah. We have to change this paradigm and support each other. Sometimes production makes a bad part. We have to figure out why and how to fix it. If we communicate not fighting, then we can understand each other and make a good part. If we continue to fight, then we have bad parts, a customer that it's complaining, and we introduce in this find the quality department.
Correct. So we have to be as assertive as we can when talking to production. This is what I understand.
Yes,
we have to
also the production have to support the measurement by not hiding the defects on the part.
Because we are trying to help them.
Yes.
In the end.
If you have a part which is not assembling, don't throw the part with the drawing and say measure everything. You try to assemble it. You saw what is not working. Where is the problem? Maybe.
Yeah.
Just go and search in that direction, because just verifying the part with the specification usually it's not complete verification of the part. Maybe you should go deeper.
Maybe you should measure something that's not on the drawing.
Yeah, evaluate in some other way and have a better understanding of what's happening there.
So everyone has to keep an open mind and try to communicate and have a great relationship. This is
and also
very important.
Bear in mind, we are people. We're working with machines and software. Everybody can have a bad day or can make a mistake.
Correct.
So yes, you can measure something, and because of the pressure, you make a rapid measurement, not judging everything, and you give a result. Here is your result. And then come back, it's not a good result.
Yeah. Usually these things happen.
Yeah.
It's normal. But if you try to fix it, I think you are a good person and a great colleague, right?
And know your limits. As I told earlier, if the specification is very tight, and your machine it's not capable of, just acknowledge that and maybe use something else.
Good. The metrology world is changing. You know that now we have PMI, we have cloud data, digitalization, we have automation, and so on. How do you think AUKOM is adapting to this kind of digitalization, and what's the steps they took towards this?
Every time a new things appears and it's big enough, they are adding something about it. Because some years ago we didn't have visual measurements. There was something with the camera as a profile projector, but it was not that accurate or that fast or anything. The technology evolved rapidly, and we have now scanners, optical scanners, laser scanners. We have
CT scanners,
and AUKOM has a chapter of each technology, explaining the goods, the bads, how to approach it, and also the inners. Because if you know how a thing works, it makes an easier use of it.
That's good. That's good to know. And I know that AUKOM also has a chapter for PMI, right?
Yes.
So do you think PMI will take over standard drawings in the future or not?
I heard of it in 2005,
Mm-hmm.
I didn't see it running, like running in production mode
Mm-hmm.
as we have everything. Yeah, it's a new thing. It will be for some time a new thing. It will be implemented because this is the trend.
Mm-hmm.
We have to lose the 2D because it's some kind of more work for the design department. Nowadays, it's the same work. You do the annotation in the 3D model as you are doing it in the drawing.
Mm-hmm. Mm-hmm.
It will go on because the industry 4.0 wants to have exchange of data seamlessly. So CAD going to production, going to measurement, going to quality. Everybody should have the same data, and the data should be enclosed in one container.
Yeah, but isn't this going to be more work for the designer because they have to do also the measurement strategy and everything inside the PMI, right?
Nope.
No.
No.
Okay, so
for now, no. So it's just specifying the specification as in a 2D drawing. So you have the datums, but you have to assign a datum to a surface or whatever it's in the CAD model. And having this, the measurement program recognizes the element that will be used for that datum. It's taking out the translation because you have to do two translations. The CAD engineer have to translate the function of the part to the specification in the drawing, and then the measurement engineer should translate from the drawing to the software.
The CAD model.
And it's taking out this translation layer.
So the measuring strategy remains to the metrology.
Remains the metrology department to be done, because it's not something that you can use on each part the same way.
Good. What skills should the modern metrology develop beyond the technical measurement knowledge, beyond AUKOM, beyond? What do you think? What is your recommendation?
Yeah, depending on the field that is working, if you are making molds, for example, you have to know how to sand, to file the surfaces to get good surface. No, just kidding.
That would be awkward.
No, that is the reality.
Okay.
You need what's called curiosity, and a drive to know more. Because if you are working in a field making glasses, you know how to measure these glasses. If you are working in a factory that makes this kind of parts, you know
the way
how to measure the parts and how to interpret the results.
But if you switch,
you know more. Every time you're switching to another field, you get some knowledge about something new. Maybe even in automotive world, from body panels, which have tolerances of some millimeters, to the interior parts, which have
less
with like a factor of 1. difference. To the engine gearbox parts, we have another factor of one, less tolerances. To the pressure pumps, you always go down in the tolerance, and the technologies to make the parts and the technologies to measure the parts are different. So you can get a new information and insight from each department or factory or whatever field where you are working.
So be curious.
Be curious.
Okay. Online learning has become bigger, especially from 2020 because of the COVID and so on. What do you think about online learning? Is it relevant enough, or is the classroom still irreplaceable?
From my point of view, the classroom is better because the interaction, it's not through a screen, and being present requires an order of presence. You cannot sleep directly or play another game on the second monitor.
Yeah, correct.
There are online classes. It can be done. I'm not a real fan of it.
Yeah, I think people who are watching are online people, and they clearly the people that are following me are people that want to know more. And from my opinion, I think people that want to know more can manage also an online course.
Yes. Also, if you want better training, you can fly somewhere or go somewhere to be
to
physically
be
present.
Yeah. Correct.
As you saw, I'm using a lot of stuff, and from your point of view, maybe you don't see everything like you being here.
Yeah, correct. Yeah, people are trying to use tables and markers
the
to
black
draw
or
and
whiteboard. It's essential on explaining different aspects of what you are trying to explain. Drawing stuff, putting something on the table or on the blackboard, it's giving a plus.
Yeah, each time. Great. One more question here. Do young engineers see metrology? How do young engineers see metrology today? Do they still see it as the dark room in the factory, or does metrology finally get the recognition it deserves?
Most of the time it's the dark room. But it gets rapidly changing once you enter inside the laboratory. Because usually the laboratories are without windows, and the people are, they don't, inside the technicians and engineers don't like to be seen. So every tour it's going around the laboratory and going out.
Yeah, just let us work in peace.
We want peace and quiet. Don't show us. But the young engineers either look at it as a very new thing and promising thing, or dark room and full of dragons. But
it's nothing to be scared of.
It's nothing to be scared of. Yeah. There are some things that should be taken in mind when you are starting working. one thing that is not pressed enough or taught enough, it's the concept of conscience. If you are measuring parts, you are giving out results, whatever kind of results, pictures or values. You have the responsibility for those values.
Correct.
You cannot give just some values.
Yeah.
Because somebody will see the values and will point the finger, and the finger will be so long because it's coming from the customer, and it's not very nice.
Yeah. We have to be careful what results we give out after we measure. We have to always check if the results are correct.
Not only correct, but plausible.
Plausible, yeah.
Because you have some values, and maybe they are out of specification, but you expect to be out of specification, and you don't look. But you have to look because the out of specification can be 2 or 3 times bigger than the specification. So there is a problem. And please don't give out results with 9 kilometers of position deviation.
So you have saw something like this.
Yeah. It was a very nice morning when the head of laboratory was screaming because the guy on the 3rd shift measured 5 parts and one of them had a position deviation of 9 kilometers. And the cycle was measurement laboratory, send out to quality send out to somebody else from quality, from that quality to the customer, and the customer to the customer, and only the last guy saw the 9 kilometers. And as I said, the finger was very long and very heavy.
It come from
From
way
far away.
back. Yeah, from far away. Yeah. Oh my God. That was a funny story. Paul, you have made a lot of trainings for a lot of people. What was the most rewarding part for you when you teach the AUKOM?
Seeing the smile on the faces that the people that understand the new concept, or they find out something new that they were struggling with. Because my trainings were not just following material, but also answering to questions. If you have a question about your work and you have art or drawing with you, we can discuss on that for some time.
Just like we did.
Yes.
We had
like
almost an entire day speaking on Calypso when
yes, we had a question that evolved in more questions, and if you learned something new, for me it was a plus.
I did learn.
You already knew the basics that we were following in that day, so we can go with the fast pace through those, and you had your knowledge about something new.
Yeah, correct, and that's the most important thing. Okay, if you had the chance to redesign the AUKOM structure like it is today, would you do something else with it?
Really, no.
No.
There are some small things, moving a chapter from one point to another, but that can be made just by presenting it in another way. But as I told you, the structure is already polished. It's evolving. So there are not many things to change it.
So it's pretty good the way it is.
Yes, it's the way it is, and
it has some years in the back. So
it has the years and the feedback of the customer and the trainers, because they always get the feedback from the trainers, and in the next version, because every year has another version. So the material, it's updated with small updates. Something changed in the ISO standards.
Yeah,
we have a new version with that update,
or the AUKOM or
whatever
ASME standards, right?
Or whatever standard. If something changes, then they make
they update it. Yeah, that's very good. What's one piece of advice you would give to a young engineer starting to work in this field?
As I said, to be curious and not to settle in one position. Because you can be considered an expert if you are working 20 years of measuring these parts. You are an expert of measuring these parts.
Yeah,
maybe. But be curious. Try to do more. Try to find out how to help production. Try to improve the fixtures. There are so many ways of doing stuff in the metrology world that it cannot be known.
Yeah, that's right.
Yeah.
I always have the feeling that I'm going, as we talked some days ago, I'm going like this up with the knowledge. I know something. I say, okay, and now I know. And then something else comes up and I'm back down.
Yeah, that's the trust in yourself curve that is going up and down following your experience. If you have more experience, then you realize that you know less than, or you have the trust in your knowledge less than before. Then you get some more knowledge and your trust goes up and it's going up and down.
Yeah, I'm glad that we had that talk. I thought that maybe it's something wrong with me or something.
No, but it's the human way of seeing things.
That's good. That's good. After AUKOM, what should people do next to continue improving? Do you have any book recommendations? This is my main question here.
Not really. There are many books. It depends on your field. Because if you are measuring glasses, and I recommend to you a book about die casting aluminium, it will be no use, no immediate use. Maybe you'll get some knowledge for later use, but immediate use, no. There are lots of stuff you can learn from anywhere, even from your channel.
Thank you. Yeah. I have a recommendation of a book. It's Measuring Strategies in Coordinate Metrology. You can also find it in the Play Store, Okay. It's written by Robert Reutheimer.
Reutmeier.
Reutmeier, yeah. I hope I didn't butcher the name because...
Yeah, Dr. Reutmeier is a partner of AUKOM.
Okay.
He's involved in the training materials and managing the partners.
I've read the book, and there are a lot of stuff there that you also cover in AUKOM.
Yes, yeah. He works at sites, and from his work with AUKOM, also sites trainings got structured, and they got some more knowledge inside, not just measurement and software.
That's great. Paul, this was an incredible conversation full of value, of insights and personal knowledge. So thank you very much for giving us the opportunity to know you, for giving us this knowledge, and to the entire community of metrology. Before we end
Thank you
this,
for the opportunity.
yeah, my pleasure. Before we end this, we have rapid fire something questions. Are you
Okay.
up for this? It's okay.
So it was not rapid fire until now.
We had a small pace, but now it's more like a question and a small answer. Not
Okay. One word answers.
not quite.
I will not be able to do it. Go on.
Okay. So, favorite measurement instrument?
Vernier caliper.
Why?
You can use it everywhere. Not in the dark. You need some light. Underwater, under oil, it doesn't run out of batteries. You can measure inside, outside. Yeah, it's called gassimeter. Yeah, it's an YouTube term from Blondie Hacks.
Okay.
But it's an all-around instrument.
Good.
Yeah, somebody will say CMM. It's rapid fire, yeah? I can go longer.
No, it's fine. Okay. Less favorite tolerance to explain.
Least favorite?
Least, yeah.
Symmetry.
Symmetry.
It's involving saying symmetry too many times, because you have in the specification a symmetry in which the datum, it's a symmetry of some elements, planes or points or whatever, and the evaluated element, it's a symmetry. So you have the symmetry of the symmetry of the refer to the symmetry. So I don't like it. Okay. Fortunately, it's it's going to be phased out.
Yeah, I've heard about this.
Yeah.
Good. Coffee or tea during long training sessions?
I would say coffee now. I don't understand coffee, but yeah, it's good.
It's good. It has a good taste, right?
No. I think for me it's like an dark liquid, sugary mostly, with milk.
Okay. ISO 1101. Love it or hate it?
What?
Do you love explaining things from
ISO
1101?
Okay, sorry.
Do you love it or do you hate it?
No, you cannot go either side.
It's not that simple, right?
No, it's necessary.
It's
enough?
Yeah, it's enough. It's enough. It's okay. One metrology myth you would erase forever.
The measurement guys don't know how to measure. We have to erase that and change it to the measurement guys are God who always give good values.
Oh my God, yeah.
But in the real way, not in the fantasy way.
I don't think this will happen.
Yeah, that was a time that it was like that.
Yeah?
Yeah, when I started, it was like that.
Okay. I was probably too little. Okay. Paul, where can people follow your work? Where can they get in contact with you?
Yeah, unfortunately, I don't have an online presence.
Mhm.
I have an LinkedIn account.
You do now.
Yes, I'm now on internet. Hello, mom. Yeah, and they can reach me through you
Okay.
if they will need something.
Okay. Thank you. Thank you. Nice to hear about this. Okay. Thank you again very much for being here. Thank you for everything. Um, to all of you, thank you for listening. If you enjoyed the content, please like, share, and subscribe, of course. If you like me to do more episodes and to invite interesting people like Paul here, please join my membership channel, my member channel on YouTube, or join my Patreon community. And until next time, as I always say, stay precise.